Okay, there were some questions on 5.3b, homework help number 69. Mostly it was in reference to one of the answers because you saw that, so you probably got this far where you factored and you solved, and you got sine of x equals -1/4, and then sine of x equals 1. And for this one, we're supposed to use the arc sine inverse functions. So x equals arc sine of -1/4, and then we have x equals arc sine of 1. We know arc sine of 1, when is the y value +1, and that is here at the top. That is at pi over 2. So we can evaluate that. That repeats every 2 pi n, or 2n pi. And so for the x equals arc sine of -1/4, we could just say x equals arc sine of -1/4 plus 2n pi. 2 pi n, whichever way you would like. Remember that sine is odd, and so really we're looking at negative arc sine. We can look at it that way. Negative arc sine of 1/4. That is the same thing. Now, what I want to do to help you understand why the other answer is true, where you would get arc sine of +1/4, and actually there's an error in the book. It should be plus pi plus 2n pi. So I did put that in my announcements in Canvas, but this is the piece they're missing because that is actually really key. Without that, it doesn't make sense. So let me refer to something that we can kind of understand just with, like, we know what the values are. Let's look at what if sine of x equals -1/2. Now we really could just think about if we're using inverses, remember that we have to restrict it to negative pi over 2 and positive pi over 2. And we're looking at when sine is negative, meaning it is at these two places, quadrants 3 and quadrant 4. Now, if we really take a look at negative pi over 6, it's actually at negative pi over 6 here. So I want to look at negative pi over 6 first. And so notice I have it on the graph here. Negative pi over 6, we can look at it in terms of to the left of the y-axis here. And then we know that it also occurs at, let's just call it 7 pi over 6. Okay. And then, we also know this is also 11 pi over 6, so coterminal angles. And looking at just the graphed portions here, we know that the value at -1/2, this first one, is 7 pi over 6, and this is 11 pi over 6. So if we're looking at arc sine of -1/2, and remember we can leave it like that, and we just say plus 2n pi, we have sine of -1/2 plus 2n pi, then that gives us our actual 11 pi over 6. Now we need to get this 7 pi over 6 here at this point. So I want us to think about, again, we're looking at the restrictions of sine. We can only be, arc sine can only be in quadrant 1 and quadrant 2, so I have to look at this value in quadrant 1, and that is positive pi over 6, positive pi over 6. Then in order to get to the 7 pi over 6, though, I have to add an entire pi to get to 7 pi over 6. So this is how you get the positive 1/2. So again, we're going to write x equals arc sine, and we're looking at the quadrant 1, so it's positive 1/2 at pi over 6, so arc sine of 1/2, and then we have to add pi to get to quadrant 3, because sine is negative, so we add pi, and then that'll repeat every 2n pi. So looking graphically, so since I already started that graphically, if we looked at positive pi over 6, it's here. And then if you add a pi plus pi, that would get us to the 7 pi over 6. So that is how is x equals arc sine of 1/2 plus pi plus 2n pi. So it's the same thing here. So arc sine of 1/4, you add a pi, so positive 1/4 is in quadrant 1, but we have to have sine is negative. So in order to get it to quadrant 3, we add a pi. So I hope this helps out a little bit more.